I want to talk about the Icinga 2 API. So just before, you know me like I'm Michael Friedrich, which also sounds terrible in English. And I'm a co-developer for like 7 years now. I joined the Icinga project in 2009. I'm maintaining the Vagrant boxes. I joined NetWise like 3 years ago for doing Icinga, just making my hobby my work time. And I recently also took over the administration at the monitoring portal. So if you find me over there, you probably have gotten a response from me. I have like 10,000 posts or something like that. Yeah, and I'm on Twitter and Facebook and Icinga, LinkedIn, whatever. So if you want to connect, just do it. But right now, I want to talk about the Icinga 2 API. This is something we developed in 2015 for, I think, 5 months for the 2.4 release. And the idea was like, we had several APIs, so you have the status file, you have live status, you have the database, and everything works somehow, but there is no clean interface. You have to pass a file, you have to connect to a Unix socket, or query some database with hundreds of joins, and we have no idea what's actually happening. And we wanted to have something like, you can actually query the core and get data, or do something with data. So we were like this, and we said, well, we want to have it like a better one. So we went for an HTTP RESTful API, which is pretty common these days. So if you're looking at the monitoring or the configuration management stack, you'll always have a REST API with that normally. We also said we need some sort of authentication and security measures for that. So we have an API user object, I'll come to that later, which is basically used for authenticating against the API. We are using SSL with X509, or you could also use basic out. So that's basically the two methods. It basically depends what you need. I'm mostly using basic out for testing, but SSL certificates also work fine in the browser. For the API user, that's basically just like, you know, the Icinga configuration language. It's an object. You give it a name, like the name you're using for basic out. You give it a password. You could also put the client CN if you prefer to use SSL certificates, and you give it permissions. In that example, it's simple. You get everything you need, but you should take care about limiting that. So, for example, if you're going the way and say, well, I only want the current API user to allow querying the object query host and services, which means you can only get the data, the current data, but you cannot modify it, you cannot write it, you cannot actually delete something, which is perfectly fine for a web interface, for a client querying data. And you can also go even further and use special filters, which is basically using the same syntax as you know from the apply rules with assign where and ignore where. In that example, it's a filter for a regex starting with Linux in the custom attribute host vars OS, but you can also use like match, use intersection, whatever comes to mind, which where you can actually limit the output of the objects as a result from the query. Yes, I will show that later on in the demo. The general idea or the general feature set, what this API should provide, is not only to like list objects. We also want to like create objects at runtime. So the old example is like you put a file somewhere and you restart the core, it takes ages, and then you have it live and it worked, cool, but all the cluster connections died, and yeah, it's basically like the old world still works. but we said, well, if someone creates an object within the API, it just put it live, store it somewhere, and make it available over restarts, but there is no restart at that time. So you put an object in, it's live. But you also want to like modify something. If you say, well, I didn't put the right address to my host, well, I just modify the address, it's live, and it's going on. And you can also delete objects. You can go like when you're having done, when you have created an object, you normally want to retrieve the information. You query all the objects, query a specific object, use the filters, whatever, to like pull all the data, pull all the attributes. It's also, we are exposing every attribute from inside the core, from inside the objects to the API. So you can also get some inside information if you're like creating a new check, on your check result, you want to see like the command line for the executed check. This is something we cannot really expose to the IDO database or to live status because the old interface is mainly in a compatibility mode, and the API just gives you everything you need. If you don't need it, you can filter it away, but basically you get everything. We also thought about the external command pipe, which is basically the interface for sending a command. You get no response because it's a FIFO. You can actually look into the log if something like rescheduling a check or scheduling a downtime actually worked, but from the call to the command pipe it didn't. With the API actions, it was designed to give you direct feedback. So you're scheduling a downtime for host which doesn't exist. You get a 500 back and say, well, okay, cannot do it. I can show an error to the user. I don't need to grab any log files or whatever. I just know if my action works or if it doesn't. So you can schedule a downtime, acknowledge stuff, add comments, just check the documentation basically. I'll also demo that later on, so it's just a too long summary for that slide already. We also said we want to have like something, a check results are happening or checks are happening. There are state changes, there are downtime events. Whatever the core triggers for an event, we want to receive that as stream. So it's possible to subscribe to event streams, which is, for example, I want to receive all the check results, but only if the service state is not okay. You can actually subscribe to that HTTP stream, which uses HTTP long polling with the version 1.1, and put that to your umbrella monitoring, reporting, you're collecting daemon, whatever you want to use. It's also helpful for debugging if you reschedule a check from the web interface and you want to actually see what happens with that. And last but not least, you can manage configuration packages. That's basically putting the normal configuration files to the REST API. There's a validation in the background, and it's restarting the core. That's mainly used for the Icinga director. I see. I have that on the next slide. The idea behind this, you have a live config which works, and you push a new configuration to it from like the Icinga director or a different tool, and the Icinga core validates that in the background and says, well, it's cool. I put it in an active stage, or it's not cool and there was an error. I'm writing a status log. You can fetch that from the API, and the old configuration which worked is still live, so you don't break your monitoring just because you're putting a wrong configuration and doing a restart, like it could have happened before. There's also support for zones in there, so if you're Using the cluster configuration sync from the Icinga 2 cluster, you can also use that. So it's basically a REST API interface where you can push your configuration based on zones or local configuration directly to the REST API. Icinga 2 does the validation and the reload in the end. The Icinga director is currently in development over there, and we will come to that in the afternoon. Yeah, sorry about that. Okay, I already said too much about the event streams. I will also show them later on. I'm just trying to go directly to the demo. You have like the check results, you have state changes. I think I missed notifications, acknowledgements, comments, downtime. So these are basically the type of filters you need to pass to the query. And the example uses, you define a queue and you define the types, which can be repeated for the URL queries, and then you receive data. I'll also show that in the demo. Yeah, and when it comes to like, you want to query an object, you want to send an action, you want to subscribe to events, it's not always like you want to select one object, you want to filter that. So you can use a simple filter where you're providing, for example, the service name, which is in that example the host name, and then the exclamation mark and the service name. Or you could go like for an advanced filter, which is using also the same Icinga 2 DSL language, like the envoy expressions. You can say, okay, I want to filter by the service name, use match, use regex, use whatever filter expression you want to use, and filter by that. But that's basically too much theory already, so I'm just diving into the demo. And I'm hoping nothing breaks, because I have a lot of demos prepared. And we need to look at the resolution. Can I make this bigger? No. Can you read that, or should I try to make it bigger? No, I think it cannot read that. View, so like zoom.
View font.
View font. Oh, font. Show fonts. To be honest, I'm not working at that resolution at work, so. Apple Plus. No, nothing. Yeah, that's. Command plus. Nee. Doesn't like me. I'm trying full screen. No, it's not that good. What's that? Yeah, okay, I'm trying my best to explain what happens. I've prepared some API queries because it's pretty much boring to look me type some curl commands on the CLI. And the basic idea is to show you some examples how to create hosts, modify them, and other stuff. And for the first part, this is a query to list all objects. For, in that example, all hosts. And if I run that, provides me an example, an overview of it's a result array, which holds all the host attributes. In that example, it's the host name C1 MySQL1. That's a demo host from the Vagrant box. I have an address set. I have the check command. And the most interesting part in that regard is I can actually get the last check result live. So I know the check source, I know the output, which is a ping check command, and I also get the executed command line. In this example, it's the check ping using these parameters, and I can go even further. I get basically every attribute from inside the core for this host object, and the next host, and so on. So basically, you get everything you need. It's JSON output, so you can pass that in your programming script, like PHP, Bash, Python, whatever. Yeah, that's basically that. You can also list a specific host, providing a simple filter using the host attribute. The host name for the demo is called Icinga 2. That's a pretty bad name, but it's basically like that. So you actually get one result. So that's mainly the local host in that regard. The local host uses also the check host alive, if I'm not mistaken, yes. And you can see that live. The same idea works with the service, using the host name, the exclamation mark, and ping 6. So these queries are live, so I just tried them before the presentation, and it's showing already results, but we'll see later on when we're actually doing something. So, okay, now for the actions. The idea is you want to send a passive check result. So for example, from SNMP traps or a remote host or something like that, you need to use the actions endpoint and set a process check result using a simple filter. And then we are sending a body. I'm looking for JSON. That's better. So actually sending a JSON body with a post request, and we set as key the exit status, which is 2, it means critically. We can set the output. We can also set the performance data as an array, and we also can set the check source. This is something you cannot set using the external command pipe, for example. And when I'm doing that, I'm running that, and then I need to switch and look for my ping 6. Ping 6, ping 6, ping 6 is critically. So if I say, well, that's not. We say, okay, let's set it back to okay, ping okay, and send it again. Oh, already refreshed, it's back to okay. So that's basically a simple example. Don't save. Oh, I hate full screen. Another example is to reschedule a check, which uses the reschedule check endpoint for the actions. Okay, yes, let's do it again. Yeah, Ben said I have 1.5 hours, so I can modify all the examples and can make trying to work with it. So okay, that's our passive check result. Now we want to recheck it, and it should go back to okay, hopefully. Hi? Yes, okay. So that's a simple recheck. You can not only do that for one host or service, you can say I want to reschedule all checks for my 10,000 hosts if I want to. You can also use a filter like if the host is in the host group Windows servers, I want to reschedule it or acknowledge it, and so on. So I think I'm quitting the full screen. Another action is to add a command. In this example, I want to add a command to all services which are ping 6. Okay. Adding a command also requires a body, which is an author in the command. It's also like the key value structure, so you don't have like a value, semicolon value, and the sixth value is like whatever. You need to check the documentation, but it's using key value pairs in JSON. So if I'm sending it, okay, I don't care, beer for the win, no. Gene for the win. And you see, I've acknowledged that. Basically, it's not a problem, but okay. No, I did add a command. Sorry. So actually, it's live. You could also add comments for various filters, various types of objects. Yeah, and that's basically the magic behind actions. The more interesting part is to create an object, which means you are sending a put request to the endpoint object, hosts, and then the name of the host you want to create. You need to pass a JSON body which holds the templates you want to import. So that could be something you define statically on disk, but you don't need to use templates if you don't want to. And you are putting the object attributes. A host object requires the check command at least, but also we can set the address for this example and the custom attribute named OS, which is set to Linux. So if I fire that, and hoping nothing crashes, and then we should have a demo host, which isn't checked yet, but soon it should be checked. The cool thing about creating an host object at runtime is that the apply rules, which are defined statically on disk, are also evaluated. So, for example, for the custom attribute OS set to Linux, I should get the SSH check, which is critically okay, because the IP address is wrong. And because of the address, I have an apply rule in the background, also assigning a ping 4 check. This also fails because, yeah, the IP address. Okay. So now I have my object. The problem is that the IP address is wrong, and now I want to make it work. So I can send a post request to set the IP address, the attribute IP address. Oops, JSON is better to read, and set the address to the actual IP address the VirtualBox demo is using. So if I fire that, oh, it already updated the IP address. I could also say check now. Oh, ping 4 recovered. SSH should recover soon, hopefully. Check now. I also could do that just from the schedule check. Oops. Filter gleich true. That should basically work like that. Hopefully, no, it doesn't. JSON. No objects found. Oh, I need to pass a type. Type if you are setting a filter, an advanced filter, you need to pass the type. So, and now I've rescheduled a check for all my services, which are pretty much. Yep. Now everything is green again. Okay. Now for deleting an object. Because when a host object is created, all the apply rules are evaluated. There are also service objects generated in the background, which means the services depend on the host. If I try to delete the host, I have a problem because the core would break on the next check when the service is there, but the host is not there. So if there is a dependency between created objects and you want to purge them all, you need to put cascade is 1, which means true, and Icinga 2 deletes the host and all the generated services for that. Or even if you created notifications for that, everything basically. If you don't do it, you will get an error and saying, well, cannot delete that host. In that example, I'm just purging everything, which is pretty much rampage. Let's see about it. I should get an error. Ignore that exception. That's not pretty, but it's not there. Just searching again, nothing found. So the host is gone. Delete multiple objects. Yeah, that would mean I need to create some objects. Let's just do that. This one. Object was created. And another one. So right now I should have 2 examples. Yes, I do. And if I want to go that direction, I'm deleting objects using a filter matching on the demo on the host name, and I'm using cascade true. And now I'm hoping everything breaks. Unauthorized, that's not good. It's using basic out. Oh. Yeah, that's. I did try to prepare everything, but. Oh, yeah. So both objects are deleted, and if I search again, nothing is there. So they are basically gone. Icinga 2 doesn't know about them. They are also deleted from the persistent cache on disk. Yeah, that's basically how maybe a virtual machine in the cloud works. You're adding it, it gets all the services applied, it gets checked, and if you remove it, you just purge it from Icinga 2 at runtime, and it's like you're used to work. So, different idea. I've created a dashboard which is using dashing. This queries the Icinga 2 API. I'm trying to a little smaller. That's basically an open source software project. It's written in Ruby, I think, and it's querying the Icinga 2 API, the status information, every, I think, 5 seconds or 1 second. And it's pretty cool if you put it on your dashboard, if in the office, just to see which problems are existing. For example, in that overview, I have some random checks for the demo, which are just changing the state. So I have 2 hosts down, service is critically warning, but I have nothing acknowledged. And just to show you, when I'm acknowledging a lot of services, I want to acknowledge services which are not in the state OK. Okay, that's me, and it's a global outage. Yeah, okay, that's my normal excuse when something happens. Okay, and it actually changed. Okay, yeah, there was a recovery, so the services remain acknowledged. And if I say, well, my admins suck, I want to remove all the acknowledgements and notify again at work or at night. No, I'm just joking. Then I could just remove those acknowledgements, and it's back to 0 again. So it's just a cool example. It also shows you how dashing works. That's on GitHub since last November. I created it for, I think, for Portland, and it's pretty much works. You can modify it. It's HTML. You should know at least some Ruby, and it's pretty awesome. So using the REST API for Icinga and showing some numbers on the dashboard. Can also integrate Grafana and other stuff into it. Which brings me to my next demo. In this example, I want to just create a check which runs every second. Which means I want to just show it on my real-time dashboard. For example, I have a new virtual machine provisioned, and I just want to see the Grafana dashboard, for example. And I'm using the check command load, which is provided by the Icinga 2 template library in that example, and the check interval and retry interval is set to 1 second. That's basically it. I'm adding that for the local host in this example. So, and this is Grafana, which did not really run in the past. Refresh. Yeah. And you can see this is mainly the graphite tree. Load real-time, just created, performance data, and I have new check lines. You see about it. I haven't found out how to refresh that automatically, but pressing buttons is also nice. No, it's somewhere in there. I'm just too, I'm not really a user interface guy. I could zoom. Yeah, okay. So you can see there's the whatever color that is, lila. So it's there, and if I want to delete it, I can do that, but I also need to make sure that the graphite backend is, I need to manually remove the Whisper data files. So I can remove that. Problem is, I will still see it, but it's not checked anymore. It will go away with the data retention later on, but I could just delete it manually. Oops. Let's do that and that. Opt, graphite, storage, Whisper, and that's basically with the dots, the structure. Icinga 2, services, load real time. It's files on disk, so I can safely remove that. You shouldn't do that in production. It's just for showing you that that's finally gone. Yeah, and it's gone. I only have my normal dashboard. You can, Icinga 2 is configured in that demo using the graphite writer, and it's just Grafana on top. You can also try that in the Vagrant boxes. It's all pre-installed over there. So that's basically what I'm using for my demo right now. Okay, that's Icinga 2 cleanup. That's basically what I wanted to show you using the PAW REST client. And then there's more. We've created the Icinga 2 Studio, or the Icinga Studio, which is an application using VX widgets to connect to the REST API. That's currently, you're just putting in your basic out information, connecting to it, and you get an overview. Can I zoom? No, I cannot zoom. About all the objects configured. Inside Icinga 2, let's say, okay, I want to see all the hosts. We have Icinga 2, and you also get all the attributes. That works on Windows. several current Linux distributions, and maybe sometime in the future Mac. The reason why I have it here is because I develop Icinga 2 on Mac directly. Yeah, that's basically, currently it's read-only. You get an idea about your objects, you can fetch that data, you can see what's configured. Oh, there's live status, okay. On the graphite writer is configured to just write to localhost 2003, yes. A more interesting example would be services, like the ping 6 check before. We have the check result, the command line. So it mainly helps us developing Icinga 2, but if you want to use that, you can do that as well. Another thing is, for the API examples, we also have the event streams. I think I show that. That's basically a bit boring because it's just JSON output. But the idea is, not the idea, you're sending a post request to the endpoint events, putting in a queue, putting in types, sending an accept header, and then watching the stream, which is a bit boring, but you can see you actually get all the check results currently happening. That's from JSON checks, not JSON, random, check load, check HTTP, and so on. And if I want to, for example, go further and filter for everything which is not okay, I can add a filter, say, okay, that's the event scope, check result, exit status is not 0, and execute that. So that's not really fancy, but I didn't have time to hack another demo. That takes a while because we actually see a dummy, a problem check, okay. The random check should also start. Hi, yeah, okay. So you get the idea. Thing is, maybe you should find your own use case for it. If you don't need it, don't use it, basically. Yeah, sorry about the general idea is, for, like I said before, if you are creating a new host, you're rescheduling a check, or you know the check interval is like 5 seconds, and you want to actually receive the stream and see, oh, it's going on, it's checking, it's nice, but it didn't really check that what I want because I missed a parameter or something like that. So it's pretty cool for like debugging stuff. We're also thinking about integrating that later on into Icinga Web 2 for like inspecting something. But we also need something for the next month to release, so just stay tuned. Yep. The time says I'm good in time. We also have created a different tool, which is the Icinga 2 console. That's basically a CLI console, like you're used to if you're a programmer. Like the Python shell or the Ruby shell, where I can evaluate expressions and so on. We have that since 2.3, but we said we want to go further. We want to connect to the REST API and provide a way to actually fetch the current objects, fetch hosts, and work with that. Print it, somehow modify it. Basically providing something like, in this example, also using the eval parameter to actually just say, okay, I want to get the current node name, current localhost, calling this function, and getting the last check result on the command line. This works live, so it's pretty much danger zone if you're connecting to your core, but you get the current output. In this example, I just want to get the command line. If I say OK, I can also do that live. I just need to copy paste a bit because I'm a lazy guy. In this example, we are also exporting the environment variable Icinga2 API password because we don't want to expose that on PS output and stuff. But you could also put it like into the connect string. This connects to the Icinga2 REST API, and now I have a console and I can say, well, I want to store the current host. It's tab completion, so it actually queries the REST API and says, what can I type? What's available? I want to get the host and say OK. And say I want to have the Icinga2 host. OK, now I have the host variable, which holds basically everything I get from the REST API directly. It's pretty long. This is basically the same you saw before in the other demos. And you can say, well, on that host object, what can you give me? So it's also using tab completion, asking the REST API which host attributes are available for this specific object. And I say, well, the last check result is interesting. That's a small bug. We need to fix that. And I want to see, I can see the command, but I could also print the state, which is 0. Or in JSON, there's only floating point, so it's floating point. That's pretty much for the console. You can also you could also fetch a service, fetch whatever. I think you give it a go and play with it a bit, because it's deep down technical stuff. Yes, that was this. And I have another example. Yes, I do have. I tried to play around with the AWS EC2 API, fetching virtual machines or hosts which are created and automatically create them inside Icinga2. So I just wrote a small script which just fetches the state from the AWS API and automatically creates Icinga2 services, Icinga2 objects, hosts in that regard. So I'm hoping the internet works. Yes, I want to start them. Thank you. It's taking some time, so I need to keep talking something. Generally, the script is over here. Yes. It's not the best Ruby code, and it's also using some deprecated stuff. Martin Alfke pointed me to, but time is also limited. I'm not sure if I should dive into that. Just hoping that they are. Oh yeah, they're running. That's good. Good. Basically it talks to the AWS REST API and then talks to the Icinga API. I'm just hoping that this keeps starting. Hello. Okay, internet sucks. Okay, cool. So Icinga2 should now have received 5 new hosts. And to prove me right, we're just searching for EC2. Yep. And we have 5 new hosts available, and the script also sets the distribution custom attribute that's just for demo purposes. And just because it has an address, it tries to ping, but the problem is the firewall is not configured on that AWS hosts. But SSH works, interesting. yeah, that's basically it. And if I stop them again, which hopefully works faster than starting them. Yes, I want that. I'm not really using AWS, it's just a cool demo. So I tried to look into Foreman and other cool stuff, but I'm not really used to that either. So it's better something you have broken in Portland, you can break now. So it's stopping. I'm hoping they're stopped. Yeah, okay. I want a Docker container. But you could also like use the script or modify the script and use it for Foreman, CoreOS, Docker, Puppet, VMware, whatever comes to mind for actually creating hosts at runtime, deleting hosts at runtime, and so on. So please stop them all. Yep. So, yep, this is stopped and it has deleted all the hosts, and I should have an empty list. Okay, fine. So, I think that was basically everything for my demo. Just one thing. I played around on the weekend a bit, and I thought it was an interesting idea. I'm used to that clippy thing, and I found a JavaScript on and I said, well, how could I make this work? It looks not that pretty, I'm not a web guy, but I think it's just funny, so enjoy it. Yeah, that was really my last demo. So I will put that on GitHub later, so you can play with that if you want to. Annoy your colleagues at work or your boss. So, we had the demo. I think that's the correct one. Yeah, so we created some API clients. So we have seen the Icinga Studio, we have seen the Icinga 2 console. You know dashing, you can find it on GitHub as well, so just play with it, or the Vagrant, inside the Vagrant boxes. Wait for Tom for the director, which is hopefully ready. Perfect. Yeah, what's next? We are seeing the community creating libraries. I think there's some Python stuff going on. I haven't seen something for Ruby, but we are encouraging everyone to just join us or join the adventure using the Icinga 2 API. We have seen users talking about Foreman hook, Puppet hook for automatic creation, for provisioning. Also using Logstash integration, like normally you would use the Nagios output and sending an external command to the command pipe, but we could easily extend that to using the Icinga 2 REST API. Maybe someone sends a pull request to the Logstash guys. I think there's the possibility to use the REST API for Naxtamon and Nagvis and other monitoring add-ons in the monitoring ecosystem. And if you happen to have some examples you want to share, we've created a new GitHub repository for that, which just collects all the fancy demos or fancy examples, which we cannot really ship with Icinga 2, but we want to share that. So we want to create some sort of, not knowledge base, but just to see how it goes and copy paste and say, well, I could use that. So the conclusion. You should download Icinga 2, I think you already have right now. Play with the Vagrant boxes. They're pretty cool, but I'm not only saying that because I created them, but they're pretty cool. You get everything pre-installed, so just run it on Windows, Linux, OS X, whatever. check the API docs. We try to ensure that they are as good as you expect them to, just to get you started and work on it and share your ideas. And your API clients, if you happen to have created one, just put it on Twitter, put it on GitHub, just share it with us. And we happily see that and receive that. And yeah, thanks. Yeah, questions. Or you're just overwhelmed.
Super. I start here, okay? And I take an Uber to come over there.
Thank you for the presentation. That was awesome. One question though, if you use the API to actually add a host, is then a host config file generated? Meaning, will it survive a reboot?
Yeah, in the background, we are actually using a config writer to store that on disk. So if you restart Icinga 2, you won't lose that information. And if you're really a hacker guy, you could actually look into that directory and check the configuration being created.
Thank you.
But just your question as well. Will it create a configuration file in the directory that we are used to?
No.
Configuration? Okay.
No. That's everything that the API is using is in varlib Icinga 2, which is used by the daemon, but it won't touch the configuration you put in etc Icinga 2. But you also need to make sure if you're trying to make both worlds work, that there are no duplicate objects, because that's something Icinga 2 won't really check. So if you're putting it in ATC and creating an API host, which is the same, the API will tell you, well, cannot do it.
Is the root password really stored in plain text?
Yeah. But you don't need to call it root, but you could...
Whatever, but it's in plain text.
It's readable by the daemon, and you should normally ensure
Security
with
through obscurity?
Permissions on disk that no one else could read it.
What about using like a hash for this?
We thought about that, and we will open a feature request or a bug report in that regard.
Just rename it to Oracle admin. Nobody will ever use it. But yes, you're right.
Okay, hi. I have a bunch of questions, but I try to condensate them into two big ones. So the first one is a general one. When we integrate Icinga with other softwares, just for example, like they did with the Monitutor, the one that we saw in the preceding presentation, I have a fear that by going directly into the database and querying directly the database and relying, for example, on the fact that the dictionary has a certain format, we are using some internal specs that may change in the future, so we lose the compatibility of the integration. So my question is, should we use always the API in order to be sure? What is your suggestion? Or can we also integrate stuffs by using directly the database?
If you prefer to use the IDO database and they're used to it and they want to keep using it, just do it. If you want to say, well, I want to use the REST API and query all the data and get all the fancy stuff, you could go that direction. We will ensure in both directions, or in every interface we create, if you upgrade, nothing should break or must break in that regard. So if we try to introduce, or if you have the idea we need a version 2 of the API, we are just creating a new endpoint, version 2, and add that. So if there's a breaking change in that regard. So like you're having a database version scheme version. Database scheme version, yeah.
Okay, sorry, the second one. From the infrastructure point of view, if we are working on a high availability Icinga environment with the REST API, and we want to submit external checks and also create objects from the external side. How do we configure this in order to be high available? Should we, for example, install more API servers and then put a load balancer in front of them?
No. If you have, for instance, a high availability cluster in a master zone with 2 nodes, and you're putting it on the first node where the API is available, you're creating a host. It's automatically synced in memory or using the cluster protocol to the second node. The same goes for any event or action you're triggering on the left side. It's automatically synced to the other one. If you say, well, I want to use that vice versa on both ends, they are talking to each other and they know the current state, the current revision of the object, and they are trying, or they're ensuring that you could use both sides. So both nodes in a high availability cluster will always share the same information. You're creating it from the API or modifying.
Okay, but if we use only one API host and that host dies, how can we continue to have a higher availability?
The other one already replicated the objects, the current events like check results, everything used from inside the cluster protocol is automatically synced. At that point, the event happens to the other node. So if one dies, the other one continues, receives check results, whatever.
But the API endpoint is
you need to make sure that the API point is available then. So if the one with the enabled feature dies, well, it's gone. So I would suggest to use both and some sort of virtual IP load balancing in front.
Yes, that's my question. Okay, thank you very much.
More questions?
I have no question, but I created a Puppet resource type that uses the API to register hosts because we needed this for our development setup, and I'll open source this in the next few weeks.
Cool, thank you.
Hello, I have a follow-up question about the API and the etc directory config files. Am I able to alter configurations that are configured via the etc config files, via the API? Say, I have configured hosts and I want to change an IP address.
No.
No, okay, thanks.
Because that's pretty, from the technical point of view, you get a mix-up. And it's pretty hard to actually determine on the left side it's the current state and it's the modified state, so no.
Okay, 2 questions. Is there a log of the API calls that you did? So we can show up, okay, this user or this call made this and this was the result? From a security perspective.
The application log logs the current requests. If you want to go deep down, you can also enable the debug log and see more about it. So if you're just trying to make a query work or an API call work, you can actually use the application log to just look into it.
Okay. Second question, you're talking about the API call in the cluster. Is this in a blocking call? So the API calls something and waits for the cluster to replicate?
No.
Okay, fire and forget.
It's a multi-threaded system, and we are ensuring that, for example, the cluster communication uses work queues and threads. And if you're requesting something using the HTTP server, it's a separate thread and actually fetching the data. And in the background, it's programmatic. It's some sort of object locking, which ensures that you only get the data you currently read from.
Okay, thanks.
I'm referring the question regarding the plaintext password. You do not have to use it. You can configure a client distinguished name in your API user object and have absolutely no password and authenticate yourself with a certificate.
Thank you.
More questions?
I think over there. Yeah, that. Yeah, people are not hungry. They need to keep asking questions.
Lunch is ready, so.
Is there any way to say I don't want to have a full response on the JSON and I just interested in the host name, for example? I don't care when the last check was run, so that I don't get a huge answer.
You can actually, I didn't show that, I missed that. You can use the Azure parameter or body, and you actually define what you want to see as an array. But you can, that's too bad, but you can look it up in the documentation. Oh, perfect.
Can you use the API with the business process logic as well?
Currently not, because the business process logic is implemented as Icinga Web 2 module.
More questions? Okay, we're good. Thank you very much.
You're welcome.